Good morning, Spaceflight Insider fans. Well, as we told you, we are at a very special location today for a very special event. As you can see behind us, one of the crew members, one of the astronauts, is getting ready to train in the NBL. And we decided this is a great opportunity to talk to the folks over at Lockheed Martin a bit about their efforts to get Orion to send astronauts to destinations such as the moon, an asteroid possibly, and even to Mars. Now, I'm joined by Jim Bray, and he's the Orion Crew Module Director. Is that correct?
That is correct.
Okay. First of all, you have a tough job.
It's a fun job. We get to design America's next spacecraft and make sure that it works for the long duration missions and these exploration missions that are going to take us further than we've ever been before.
Now that's a great segue into what we want to talk about. Talk to us a bit about how these crews are going to work with Orion, how they're going to interface, and how what we're seeing here relates to what Lockheed Martin is doing.
Here in the Neutral Buoyancy Lab, we're bringing the Orion crew module in and setting it down in the pool. This is the crew module that's actual scale of the Orion crew module, and we use that at the Neutral Buoyancy Lab to be able to test out different scenarios, crew access, ingress and egress as it's in the water. After the astronauts return from the moon, we want to be able to make sure that they can get safely out while they've landed in the water. We also use the Neutral Buoyancy Lab to be able to test out the uprighting bags to make sure that if the crew module lands upside down, that the crew has an excellent chance of being uprighted so that they can get out through either the side hatch or the forward tunnel. On Orion, we've always got two different ways to solve a problem. So we've got two different hatches, and we want to make sure that the crew is able to either get out through the side hatch, which is the baseline plan, or through the forward hatch, which is the emergency plan.
Now, a good question there is, Orion's been in development for a little while, and I'm sure that there's been some changes along the way, but we have an astronaut behind us, two, I believe. One was helping the other one suit up. How has that worked? How have you got the astronauts to help you develop Orion to send these crews to deep space destinations?
You know, it's interesting. We're given a set of specifications on how the spacecraft is going to be designed, but that can't tell you everything. So we bring humans into the loop and the astronauts into the loop as we design the spacecraft to make sure that everything is right, that there's no glare that's going to prevent them from being able to see the screens, that they're able to have good lighting in the cabin, that when they reach up and they open the crew module hatch, that they're able to reach that and that they've got leverage. Because if you think about it, when they land in the water and the crew module's there, the crew, if they need to get out in an emergency, they have to get out through the forward hatch. And so that has to be able to be opened while they're bobbing around like a cork in the water.
So Jim, I've heard an acronym here, and as we're very well aware, NASA loves them some acronyms.
We do string together letters, and we eventually get to come to understand what they mean.
So one of the things we're very proud of at Spaceflight Insiders, our name doesn't refer to us. The insider is our guests, and so we bring them inside. What does HITL stand for?
It stands for Human in the Loop Testing. And if you look at it, what we really want to do is get the astronauts to where they're experiencing the crew module before they get out into the environment of space. So they have a chance to influence the design and make sure that it is the spacecraft that they want to be in up to 6 months.
Right.
And so we want to get the lighting right, we want to get the cabin circulation right, and we want to get the access and reach issues solved so that when they're strapped into the seat, they can access what they need to, whether they're the 5% female or the 95% male. We want to make sure that there's good reach and range of motion for the astronauts to be able to.
Now, you talked a bit earlier about the glass cockpit inside Orion, let's just say that, and that they had to make sure they have their helmets on and that they can see all the numbers. Now, that's a very complicated thing, but there's simple aspects like, for example, the windows on Orion and the color that's around those windows. Why don't you tell our viewers a little bit about why the windows are the way they are on Orion?
Before we got to our preliminary design review, the first crew module that we had to design was the ground test article. And we wanted to make that as flight-like as possible. We got crew that were seated actually in seats in a mock-up crew module, and we had targets on the outside of the crew module, and we looked at positioning the windows to where they had maximum visibility. Again, the 5% female to the 95% male, we wanted to make sure that they could see out the windows in a seated position. So we positioned the 4 different windows at the right angles for maximum viewing angles. We coat the outside of those windows with a black coating to absorb light to make sure that there's no reflection and that they can actually see out. The other thing that we do is we control the cabin air on the inside of the crew module so that there's no fogging and there's nothing that's going to prevent them from being able to see out the windows and get their sights.
So, final question, Jim. If you had to basically tell our viewers anything about Orion, I wrap up most of my questions this way. What do you think sometimes gets lost amid all the noise, all the different talking points and everything? What would you want our viewers to know about Orion, how it's been developed, and where it's going?
The thing I hear most often is, why does Orion look like Apollo? Why couldn't you have done something different? And the reason is because the physics work out that is the best way to design a crew module for deep space missions. What we don't get to see is that it may look like Apollo, but it is a completely different vehicle. It's the safest spacecraft that's ever flown. We've looked at backup systems that you don't have to have if you can get back to Earth in a relatively short time frame. So we look at everything that could be a possible failure mode, and we design that out. So there's dual access for everything, there's alternates, and there's backup plans. And that's the thing that the average person wouldn't be able to see, is just how safe the spacecraft is and how it's really ready to go to places that America has never gone before.
Well, Jim, I don't think we can possibly end the conversation better than that. We really appreciate you taking the time out of your busy schedule to talk to Spaceflight Insider. Good luck and go, Ryan.
Great, thank you.